everyone, this is part 2 of Operations on Radicals lesson number 2. Moving straight into class example number 2. This is on page 102. So last time we left off where I asked you to see if you can complete this example on your own. Our goal here is to simplify each of these radicals. I'm just highlighting the radicands here. Our goal is to factor them and simplify it so that we can actually add and subtract. Because remember, we can only add and subtract like radicals. So go ahead and start with 108, and I hope you have a calculator handy with you. I'm just trying this out. 108 divided by 4. Okay, that gives me 27. 27 is not a perfect square. So I wonder if I can try something else. 27 is divisible by 3, so I'm going to go ahead and try that. Great, so now I know 4 times 3 times 9 works out. I'm going to keep this because 4 is a perfect square and 9 is a perfect square, so I can factor those out. I'm going to try my next one here, which is 8. 8 is equal to 4 times 2. That works because 4 is a perfect square. 48. Again, 48, I can see right away that's divisible by 4 because the last two digits are divisible by 4. So by divisibility rule, that must work. And if you don't remember that, that's okay. Just try it out on your calculator. Now I get 4 times 12. Again, I see that 12 is something I can break down even further. So I'm going to go ahead and divide by 3, and that leaves me with 4. So I have two perfect squares from here. If I have 4 times 4 as a part of this particular radicand, that means I can factor out an entire 4. Last but not least, let's try 50. 50, I'm going to go ahead and do divide by 2. That leaves me with 25. Great, square root of 25 is 5. Again, any of these quick maths that you're not too sure of, go ahead and use your scientific calculator for that. Now I'm just going to rewrite it into my radicals form. Remember to always show your work, so that's what I'm doing here. I'm rewriting it, even though I know we can see it fairly clearly in the work above. And that's just to make our step-by-step equations actually equal to each other. And I've just highlighted my radicands, or the parts of the radicand that can actually be factored out as a perfect square. So for my first term, then I have negative 5 times square root of 4. That gives me 2. Square root of 9 gives me 3. And all I have left remaining inside the radicand then is square root of 3. All right, let's move on to the next one before we come back and simplify this. 3 over 4 times square root of 4, which is 2, times square root of 2, minus 5 over 4 times, this one, instead of breaking it up as square root of 2 times 2, which is square root of 4 times square root of 4, again, because if we have the two same numbers multiplied, we can just factor out an entire square root of 4, or square root of 16 actually, which is 4, times what's remaining, 3, plus 1 over 2 times square root of 25, which is 5. And what's left here is just the 2. All right, now next step, we just have to multiply our coefficients and combine that into one number. And then I wonder if you can see here are the like terms. Anything with square root of 3, that's a like term. Anything with square root of 2, those are like terms. So we can just add and subtract those as if we're working with coefficients. I'm going to show my work and do that in 2 separate steps. You can see now my coefficients have been simplified. Now I'm going to combine my like terms. I will do the pink like terms first. Because I have a radicand that is 2, and the radicand 2 is smaller than the radicand 3. It's not a fixed rule here, but it's similar to when you line up your algebraic terms. We want the smallest terms, or we want the largest terms to come first. So when we're working with radicands, we tend to want the smaller terms to come first. But again, it doesn't have like a fixed rule. Another reason I'm choosing these is because I know that's going to be positive at the front. 3 over 2 plus 5 over 2 would be 3 plus 5, which just gives me 8. So then I have 8 over 2, which I can simplify to 4. So I'm going to write my first coefficient as 4 times square root of 2. Next one we're dealing with is the negative 30 minus 5. So that gives me minus 35 times square root of 3. And we're done. Continue on to example 2b. You can pause this video to see if you can do this on your own. I will show the answers here in 3, 2, and 1. Step 1, I've broken each of my radicand down into individual factors so that I can see a repeat of 3 factors because we're dealing with cube roots here. Once we've done that, you can see there's some simplifying we can do here. I'm just highlighting the parts that we can simplify, and those are the coefficients. In fact, some of these coefficients simply cancel out from our numerator and denominator. And that leaves us with just 2 like terms to combine, a positive 10 times cube root of 3 and a negative 5 times cube root of 3. That's our final answer. Last example for this lesson is on page 103, and we're looking at a word problem. It says to find the length of x. Here's x as an exact value and then as a decimal. Okay, so let's first think about this. We have a longer length here. We want to subtract this length in order to find our missing x. So let's form an expression using radicals. When you're forming this expression, don't forget to put brackets on your second expression, especially because we actually have a negative sign. Oopsies, a negative sign here in our second expression. If you don't put brackets around it, that's gonna give you the wrong sign altogether. Okay, when we combine this minus minus, we end up having a plus. The same strategies as our last question here to simplify my radicals. And I've just written out here the perfect squares that we can factor out. Your simplified radicals, and now we're just picking out the like terms. Again, you're looking for radicands that are, radicands that are exactly the same. So I'm highlighting ones with square root of 3, and I'm highlighting the ones with square root of 2. There's our answer. Again, not at all crucial, but I'm just putting my smaller radicals at the front there. It is a word problem here, so we've answered part A. This is number of units that would represent x. And for part B, then you would just punch the whole thing in your calculator. And please do practice doing this. But the answer is 9.2 rounded to the nearest 10. That's it. Homework questions for today is just a continuation of what you worked on last time. On Friday, I had assigned for you questions 1, 3, and 6. So today you can work on 7, 8, 10, 11, 12, and 13.